In today's lesson, we're going to talk about parallel lines and transversals. To begin with, we have some definitions. Parallel and skew lines. Parallel lines are coplanar lines that do not intersect. Here's line A and line B. To indicate that two lines are parallel, we use arrows. Notice that the arrows go in the middle of the lines. That's indicating to us that those lines are parallel. There's A, there's B. Arrows are used, as I said, to indicate that the lines are parallel. Remember, the symbol for parallel is this, kind of looks like the number 11. A is parallel to B, is how you read that. Line A is parallel to line B. So parallel lines, coplanar lines that do not intersect. Skew lines. Skew lines are lines that do not intersect, but they can't be parallel because they're not coplanar. Take a look at the box. The box is a great way for us to illustrate skew lines. So this, the front left edge and the top right edge, those are skew. They won't intersect, but they're not coplanar because they're not both on the top or on the side or anything. Those are skew. The other thing we talk about with this is parallel planes. And parallel planes are simply planes that do not intersect, such as the front of the box and the back of the box. So just like parallel lines that don't intersect, parallel planes also don't intersect. Next, let's talk transversals. A transversal is a line that intersects two or more coplanar lines at different points. Let me demonstrate. Here's a line. Here's a second line. The red line is the transversal because the red line intersects the two coplanar lines at different points. So it can't be that all three lines come together at the same point. That would not make it a transversal. The transversal has to intersect it at two different points. When the transversal intersects the two lines, it forms 8 different angles. 1, 2, 3, 4, 5, 6, 7, and 8. 8 different angles formed by a transversal intersecting two coplanar lines. Next, we're going to talk about what special angles are formed when the transversal intersects our two lines. And the first thing we'll talk about are internal angles. Internal angles lie in the region between the two lines, such as 3, 4, 5, and 6. Those 4 angles are interior because they're between the two lines. Exterior angles lie in the two regions that are not between the lines. In this case, above and below. So it would be 1, 2, 7, and 8. Those are the exteriors. So the interiors again lie between the two lines, 3, 4, 5, and 6. The exteriors fall outside the two lines, 1, 2, 7, and 8. Now, we also get a little bit more specific with angle pair relationships. Remember, a pair means 2, so now we're going to start pairing up our angles. And the first pair that you have to recognize are what's called consecutive or same-side interior angles. You'll see it referred to as both ways. They're interior angles, so they're going to have to be between the two lines that lie on the same side of the transversal. 3 and 5 would be an example of consecutive interior angles. Also, 4 and 6. 3 and 5, along with 4 and 6, form our consecutive or same-side interior angles. Next, it's the alternate interior angles. They're non-adjacent, so they can't share a side and a vertex, that lie on opposite sides of the transversal. So they're interior, so they're going to have to come from 3, 4, 5, and 6, but they can't be adjacent, so it can't be 3 and 4, because 3 and 4 share this side. So your alternate interior angles, 3 and 6, because 3 is up here, 6 here, again interior, and they alternate sides of the transversal, 3 to the left of the transversal, 6 to the right. Also 4 and 5. 4, 5. Changing sides of the transversal, but staying inside. Now you might be saying, well, 3 and 4 do that. That's why we have this part of the definition, non-adjacent. 3 and 4 are adjacent angles. They can't be alternate interiors. Alternate exterior angles. Again, they're non-adjacent that lie on opposite sides of the transversal. So 1 has to be alternate exterior with 8. 1 and 2 can't be alternate exterior because 1 and 2 are adjacent. They both share this side as a common side. 7 and 8, non-adjacent, or adjacent because they share this side. So the alternate exteriors we would have would be 1 and 8, along with 2 and 7. One more special pair to talk about in this lesson, and it's these. Corresponding angles. Let me get out of the way here. They lie on the same side of the transversal and on the same side of the lines. Corresponding angles are thinking about this. Imagine if we picked up these two lines and put them on top of each other, what angles would fall on top of each one? Same side of the transversal, same side of the lines. So 1, notice here, is left of the red transversal, and it's above the coplanar line. So it would match up with who? You're right, 5. 2, to the right of the transversal and above the coplanar line, what would it match up with? You got it, 6. 3, left transversal, below the line, just like 7, left of the transversal, below the other line. And finally, 4 and 8. Everything we talked about on the last slide, if we go back here, you only have 2 of each pair. You have 2 pairs of consecutive same-side interior angles. You have 2 pairs of alternate interior angles. You have 2 pairs of alternate exterior angles. Correspondings, on the other hand, we have 4. Count them, 4 pairs. And as we talked about, 1 and 5, 2 and 6, 3 and 7, 4 and 8. Those are the special pair of angles and the transversal angle pair relationships that you have to know going forward here in Chapter 3.